Hello and welcome to Introducing RESTful APIs. In this video, we're going to cover the definition of REST, or the representational state transfer that's used in designing web APIs. We'll talk about HATEOAS and why it's important, and that's another initialism there for HTTP as the engine of application state. We'll talk about how HTTP verbs work and how they map to create, read, update, and delete operations. And we'll discuss some common HTTP responses. Now, all of this is building up to later videos where we'll talk about how we can use these concepts to design our own custom RESTful API. So let's dive on in. What is REST anyway? So REST is a term that is thrown around a lot in programming communities. It comes from the thesis of Roy Fielding. He actually wrote about the representational state transfer architectural style. So this is not actually a specification like SOAP or XML RPC or other protocols that you may be familiar with. This is more of an architectural style, and it describes the way that the web works and why the web has been able to scale as well as it has over the number of years that it has. So we'll look at some of the different aspects of REST later on in this video, but that's the background. What is REST? What does it stand for? So the main ideas of REST are, number one, we design our API around resources. Now, as far as the web goes, those resources are typically web pages and images and things like that. So if we're designing an inventory system, we might have a stock keeping unit or a SKU being one of our resources. We could also have a warehouse being another one of our resources. Say we have a multi-site inventory system. We might have a pet store. That's another common API example. And one of our resources might actually be the collection of all of the pets that we have. So that would be a pet collection resource. Now, the thing about resources in a RESTful API design is that they can be located and identified. And so that's what we use the URL or URI for. And that is either the Uniform Resource Locator or the Uniform Resource Identifier. Now, these are often used interchangeably. Technically, a URL can always be used to find a resource on the web, and a URI is anything that identifies the resource. Usually the URIs will also be URLs. The second concept that's important in RESTful APIs is the representations. Now, these resources that we've talked about before are kind of abstract resources, or they represent things in the real world, not things in our application. The way that those things are represented over the wire when we send between the server and the client, those are the actual representations. So in the web, those representations typically are HTML web pages or JPEG images or videos, things like that. So it could be HTML, could be XML. That's a common representation when we're dealing with APIs. That was popularized by SOAP and XML RPC. So lots of different protocols use XML, and more recently JSON or the JavaScript object notation has become very popular as a representation format. This is something that is a little bit more readable sometimes than XML. It looks like JavaScript objects, and that's where it gets its name. The third main idea in REST is hypermedia. So hypermedia is the idea that you have a representation, and that representation has links to other representations or other resources. So in HTML, we see this with hyperlinks, or the links that you can click on from one page and take you to another page. Hypermedia is a little bit more general. It could be any media that contains these links to other resources that you could retrieve. So those are the main ideas, and out of the hypermedia we actually get a second big idea inside REST, which is HATEOAS. So this is a pretty big acronym, or a mouthful to say. So HATEOAS stands for HTTP and the engine of, hypertext as the engine of application state. So the basic idea here is that your RESTful APIs should be discoverable. So when you think about it on the web, all that you need to use the web is a single URL, and often that's Google. But that single URL takes you to a resource, which might be a search results page, might be a search query form, but it has links to other pages, and you can click on those and you can find the other pages, and you can navigate this web of documents without having any external documentation that says you need to go here to look at this, you need to type this into your URL bar and things like that. So hypertext as the engine of application state means that you don't want there to be this sideband communication, this separate map of what the API is or what the web is. You should be able to discover it. So if you have a properly HATEOAS design, a client would be able to use your API without any prior knowledge of its URL structure. So that would mean that you wouldn't need, like, you should still publish documentation, but technically the client would still be able to use your API and discover it and play around with it without having the documentation ready at hand. The second thing is that all of your resources are located using URLs present in other resources. This is really how you get to HATEOAS. So the web gives you this for free because you've got hyperlinks. If you have a page which is not linked anywhere, then that's kind of an orphan page. It doesn't really participate in the design of the website. You can have broken links, links that go to resources that no longer exist, things like that. But generally, the web works like this. In a HATEOAS API, we reference all of the other resources by their hyperlinks. And finally, there's a single root URL or entry point that's used to discover everything else. Now, one of the nice aspects of a HATEOAS design is that our client and our server can evolve independently. So if you are writing clients for a HATEOAS API, say you're writing a web client and a JavaScript client that's running in the browser, it's using the API quite a bit. If you follow the links that are discovered through the API, then as the server evolves, as the author of the API on the server changes things, maybe refactors and moves URLs around, your API should still work, or your client should still work, because all of those links, you discovered them anyway through other resources. As long as that root resource can still be found, you should be okay. So REST as an architectural style doesn't technically require to be sent over the web, but usually it is. And the web's protocol is HTTP, or the Hypertext Transfer Protocol. This is a pretty simple protocol. It's text-based, and the main ideas of it is that it has to do with requests and responses. The core idea here is that the web is actually a RESTful API, and we're going to map RESTful concepts onto the web and see how we can actually build RESTful APIs on the web. So the web, if you look at it, actually has a very small number of entry points. We've mentioned already you might start off at Google, you might start off at a home page, and you kind of discover everything from there. Everything on the web can be fetched using URLs from other resources. So you can find everything on the web from everywhere else. And finally, the browser negotiates the exact representation of each resource. And this is a concept that we haven't really talked about much up until now, but your web browser is actually doing a little dance between you and the server and deciding, for this resource, I would like to see the HTML version of it. Or maybe you're on a mobile browser and I'd like to see a reduced quality version of this. And it can communicate this through the HTTP protocol of the types of representations that it's interested in seeing. Same thing for images and videos and things like that. Your browser actually does a little bit of negotiation on the exact representation. So let's look at HTTP. This is the protocol of the web. HTTP has two main actors. One is the user agent. That's just a fancy word for your web browser usually. And it is the client in the HTTP protocol. We also have the resource server. We might also call this a web server or a website. And these are two pieces of software, and they're going to communicate over a network by what we call a request and response cycle. So what happens is when your web browser wants to see a page, it sends a request. And that request might look something like get/page.html. And so it's telling the server, please send me the contents of the resource or a representation of the resource at page.html. And then the resource server sends back a response which has a header line, tells you that it's okay, and then it gives you that representation. So those are the basic ideas, and now we're going to look in a little bit more detail at the actual request and response. So the request, there are different components of a request. This is a GET request. The first thing in your request is actually the verb or the method. So when we look at REST architecture, REST is organized around resources. Those are the nouns of our architecture. So it would be our pet store or our SKU or our warehouse, things like that. The verbs come in the protocol. So these are things like get, and we'll look at the other verbs as well. So get is what we want the server to do with a resource. Then we have the URL that we're requesting. In this case, I'm just asking for the root URL or /. And then finally, on the header line, I tell it what version of HTTP I'm speaking. We won't really talk much about this. Most of the time, it's going to be HTTP 1.1. After the header line, we can have some headers. And these headers will give more metadata about the request. It can say, what user agent am I using? In this case, I used a command line web browser called curl. It will also say what sorts of content can be accepted by this browser. Curl can accept anything that the web sends it back. So it says I accept any type of content. It also is saying which host am I targeting. So I'm actually looking at google.com, and this will allow different web servers to actually host multiple sites with the same physical hardware. And then in some web requests, not in this one, but in many web requests, we have a body of the request. And that's when we actually want to send a representation of a resource up to the server. And we'll get into what some of those verbs are that take bodies in just a moment. So some of the verbs that we might look at and we might use in HTTP would be get. Get is the one that we've already seen. That is retrieve a resource or a representation of a resource by a URL. So that's the one that's most common. We also have a put request, and that is either a create or replace a resource at a URL. So the idea is we're going to send a put request. The body of that request is going to be a representation, and what we're saying is we'd like you to make the resource at this URL look like this representation. We also have delete, and that's just a request that a resource at a particular URL be deleted. And we have post, and post in the HTTP standard basically means do something else. We often use it for creation where we don't know what the final URL will be, like if the server is going to assign a URL and create a URL for a resource. So we might send a post request to please create this resource. In the web, as it's been used traditionally, like the older web, get and post were the ones that were used the most. These were getting the resources is just normal link clicking, and posting is how forms would work. So it would actually take the contents of a form and send them up as a post request. So these different verbs have, or these different methods have different aspects to them as well. So there's certain questions we can ask about each one of these verbs. Are they safe? Can you issue a request with this method willy-nilly and not worry about messing up data? The second question is it idempotent? Meaning if you issue it and then you lose connectivity and then you issue it again, are bad things going to happen because it's not idempotent? In other words, it's changing the server in ways where you can't repeat the request and have the same behavior. So if you had some request that increments a counter, that would not be idempotent. Also, does it have a request body? And that's just more of a functional aspect of this request. Do you actually send a body along with these? So we can put these verbs on a grid and determine what the aspects of each one of them are. So get is safe, it is idempotent, and it does not take a body. So you can issue as many requests as you want. The server is going to respond in the same way each time you issue them. And the nice thing about it is it's safe and idempotent, so you can actually put a caching server in front of a web server, and you can handle all the GET requests there and make sure that, offload some of the work onto that caching server. Put requests are not safe. They could change things on the server. In fact, they're intended to change things on the server, so you shouldn't just do them. Say you've got a web crawler, you shouldn't be issuing put requests in that web crawler trying to index the web. You should assume that they're idempotent. So if you put a request and then you put the same representation back to that request, it should have the same effect as if you had just done it once. And it does take a body. Of course, you do need to send the representation that you're putting. Delete is not safe because it's changing something on the server. It is idempotent, so if you delete something multiple times, it shouldn't do more than deleting it once. And it does not take a body, so you don't need to send a body along with your delete request. You just say delete the resource at this URL. And then finally, post is neither safe nor idempotent, and it does take a body. So posts, again, are for these, do something other than get, put, or delete. Usually we'll use it for creation. So another acronym that you may have run across in designing APIs or designing systems would be CRUD, and that's just short for create, read, update, and delete. It talks about the different things that you can often do to databases or pieces of data in a database. So how do we map these create, read, update, and delete operations onto the REST verbs? Well, create we've already seen can be a put, and that is if you know where the resource is going to be located, you can put to that URL and create the resource there. Create can also be implemented using post, and this would be when you don't know where the resource is going to be, you might do a post to the collection. So let's say you wanted to update your pet store to say now you're going to be carrying snakes, so you're going to post a snake to the pet collection, and then the response to that post will tell you where that new snake has been stored, or where that new snake category of pets has been stored. We also have reads, which of course map to gets. Updates are typically implemented using put, and deletes are implemented using delete, which shouldn't be surprising to anyone. One other thing that I will mention is that there is another verb that's sometimes used called patch, and patch is used for sending a partial representation of an object. It is a little bit behind the other verbs in acceptance and standardization, so we won't really talk about it too much, but just be aware that sometimes you might see a patch. Patch is not standardized in terms of what's sent as far as the resource goes, or as far as the representation of the update goes. So just be aware of that. So that's the requests and all of the request verbs that we'll actually be dealing with. There are other verbs, but those are the main ones. We'll now look at the response. So this is what a response might look like. This was actually part of the response that I got back from Google when I did that request, and we can look at the different aspects of it. Now the first thing that starts off with is the HTTP version in a header line there, and again this is almost always going to be HTTP 1.1. It should match the version that was requested by the client. We also have the response status, and that's going to be important. Well, sometimes we'll call this the status code or response code. This is the overall response of the server to say, did the request succeed, and what are the high-level things that we can tell you about this request. We can also have headers. We'll have the data of the request that comes back. We can have cache control information. We might have cookies being set or deleted in the headers. And then finally we have a blank line, and we have a body of the request. These are optional. In the case of a response to a GET or a 200 OK response, we'll typically have a body. And this would just be the HTML of the Google homepage in this case. So let's look at some of these response codes. These can be a little bit confusing to people. Sometimes you might have seen some of them and recognize them, but generally they're grouped into different categories based on what the first number of the code is. So anything that starts with a 1 in the 100 level is an informational message. And these are sometimes used for protocol level things, like if you get into WebSockets, there's an upgrade request, which is a 100 level message, or a 100 would mean, yes, I got the beginning of your response, please go ahead and continue, or I got the beginning of your request, please go ahead and continue your request. These are used for streaming and things like that. We won't look at those in too much detail. Then we have the 200 level or success responses. These are typically, they mean everything's okay. So a 200 OK is the most common one. That's when you do a GET, you get a 200 OK, and the body of the representation comes back. We can also have a 201 created. This would be a special response that is like an OK, but it's also saying, I created a resource for you on the server, and typically you'll send back the representation of that resource that was created in the 201. You can also have a 202 accepted. And that means maybe you've started a process that takes a while to complete. So it means that the server has accepted your request and is working on it. It doesn't mean that the success necessarily succeeded. It just means that it's working on it. Sometimes the body of the request or the headers might have another URL that you can go and check on the progress of that request. 204 would be a no content. That's a special header that says don't look for any representation in the body of this response. I'll often send that back for a delete request. So you try to delete a resource, I don't need to tell you anything other than I deleted that resource, so here's a 204. Then we also have redirects, which you may have seen. Redirects would mean your request was okay, but you need to look somewhere else, basically. A 301 is moved permanently. This is when you refactor your website or your URL structure and you want the browser or the client to update its bookmarks. This is a 301. So this is what people use for trying to transfer your search engine optimization from one website to another or from one URL to another, and you want to make sure that Google remembers all of your new links. You'd give a 301 moved permanently. More commonly in APIs, we'll see a 302 or a 303. These are temporary redirects, and technically that means 302 means found, 303 means see other. And what that means is I got your request, and to complete this transaction, you need to go to another URL. So sometimes forms will do this. You'll accept a form for processing, send back a redirect to the resource that was just created, or maybe back to the resource page to edit that resource, something like that. But it's a redirect, means go somewhere else now. We also have error responses that can come back from the server. The 400 level responses mean that the client did something wrong, and the 500 level responses mean that the server did something wrong. So on the 400 level responses, 400 by itself just means it's a bad request, and that could mean any number of things. Oftentimes I will send this to indicate that there's a problem in the body of your request. So maybe you sent a representation which I didn't understand, or you had some errors in the representation, like you needed to supply certain fields and you didn't, so I'll give you 400 bad requests and then more detail in the response. You can also have a 401 unauthorized, and that will typically pop up a login dialog box if you do it in the web browser, but it means that the user was anonymous, or the client was acting anonymously, and this particular URL requires authorization. It requires you to identify yourself. 403 is forbidden, and that is not that you are acting anonymously, but maybe you're authenticated, but you're not allowed to see this. So you send back a 403 forbidden. You can also send a 404 not found. That's when there's a resource requested at a URL, and there is no resource at that URL. So that's the one that you've probably seen on the web different times. People have their 404 error pages. Sometimes they'll be funny. Sometimes they'll have search pages on them. But 404 not found is where that comes from. 405 is method not allowed, and that is when there's a resource that does not support the HTTP verb you're trying to use with it. So let's say we sent a delete request to a pet collection. Well, we don't want the user to be able to delete all of the pets in our pet store, so we would send a 405 method not allowed. You can't send delete requests to the collection object. 409 is conflict, and that would be if you're trying to create a resource and someone else is trying to create a resource at the same URL, or there's some other kind of a conflict, like maybe two people are trying to register the same email address on your user as a username on your website. You might give one of them a 409 conflict. That user already exists, that email address is already in use. And then 410 is gone. 410 is kind of like a 404, meaning there's no resource at this URL, but 410 means there used to be one. So it used to be here, but now it's gone. So those are the different things that the client can do that would be in error. Then there's also the server can be in error. The most frustrating one that you probably have run across is 500 internal server error. That's a catch-all. That means something went wrong on the server. And as you're developing APIs, you'll probably run across those quite a bit. We can also get 502s, 503s, and 504s. Those are typically errors that come when you're using two servers together. One is a proxy server or a gateway server to another server on the back end. And if the server on the back end is not working or there are other errors in it, you'll get one of these errors typically. Bad gateway service unavailable or gateway timeout. So we won't really worry too much about those, except to say that you probably need to look at your back-end server behind a proxy when you get those errors. So in this video, we've learned several things about REST APIs and HTTP, and so there's certain questions that you should be able to answer now. One is, what is a RESTful API? What makes up a RESTful API? And why is that important? What is HATEOAS, and why is that important? That's the HTTP as the engine of, hypertext as the engine of application state. Why is that important? Why is it useful? How does the HTTP request and response cycle work? What are some HTTP verbs or methods, and how do they work? And then finally, what are some CRUD operations? How do we map those CRUD operations onto those HTTP verbs? And actually, finally now, what are some common HTTP response codes, and what do they mean? So I hope that you've enjoyed this video, and there will be more if the response is good. So please like it and comment and subscribe to this channel. Thanks.